Assalamu alaikum guys, welcome back to another lecture of digital signal and processing, and today we're going to be discussing an example of discrete time Fourier transform. तो अगर हम एक example if we take an example कि x of n is from 0 to 3 and number of samples are 0 to 3, and is capital N is equal to 4, and these are the amplitudes which are for 0 we have 1, for 1 we have 2, for 2 we have 3, and for 3 we have 4. अगर हम इसका हम discrete time Fourier transform हासिल करना चाहेंगे, so there is a formula for that. This formula is x of k, which denotes the discrete time Fourier transform, is equal to the summation of x of n from where n is from 0 to capital N minus 1 e into e की power minus 2 pi n of k by n, where k is the number of frequency components, n is the number of samples, x of n is the sequence of the signal, and n is the number of sinusoidal impulse in the time domain. Now if we get back to our question, when we input the values we have n is from 0 to n minus 1. This is the formula written over here. Now when we input the values we have n is equal to from 0 to 3, n minus 1 when n was 4, then minus 1 we get 3. X of n is equal to minus 2j pi k of n by 4. Here we have on further simplification e to power minus j pi k n by 2. Now when k is equal to 0 we have x of 0 and from n is equal to 0 to 3, x of n is equal to e की power minus j pi n, and there is k input 0 which is 0. तो क्या होता है हमारे पास कि e हमारे पास हो जाता है e की पावर 0 which is equal to 1. तो हम इसको निगलेक्ट कर देते हैं आगे. x of 0 which was equal to, I think x of 0 was 1, x of 1 was 2, x of 2 was 3, and x of 3 was 4. Pretty simple example. तो ये क्या हमारे पास आता है कि x of 0 e की पावर 0 1 है, तो वो हम 1 को निगलेक्ट कर रहे हैं क्योंकि मल्टीप्लाई करके हमारे पास we get the same answer. x of 0 is equal to 1. Here we have 2, 3 and 4. When we add them up we get 10. For k is equal to 1 we have n from 0 to 3, x of n e की पावर माइनस 2j n, क्योंकि 1 है तो वो मतलब मल्टीप्लाई होगा तो देन वी गेट द सेम वैल्यू n by 2. नो फॉर x n की पावर 0 we have x of 0, when we input the value of n we got 0 e की power 0 because n multiplied by this whole term we get 0, and we have when n is equal to 1, then this minus j pi by 2. When n is equal to 2 the 2 cancels out, we get minus j pi, and when 3 we get minus j 3 pi by 2. So when we simplify this the whole expression on by the help of calculator we get minus 2 plus 2j. If then we have to take the mod. When by taking mod we get under root 8 or 2 under root 2. Now for k is equal to 2 we have this following sequence. The x of 0 we have 0 e की power 0, and for x of 1 we have 1 minus 3 j pi by 2. X of 2 we have minus 3 j pi, 2 cancels out, and for this we have x of 3 e की power minus 3j 3 pi by 2. If we simplify then again we have minus 2. Now if we take the mod we'll get positive 2. For k we have minus 2 minus 2j, which will be equal to under root 8 or 2 under root 2. Now if we want to plot this sequence in the frequency domain for discrete time Fourier transform, we will have something like this. For k is equal to 0 we had 10. Here we have 10. For k is equal to 1 we had 2 under root 2. 2 into under root 2. For k is equal to 2 we had 2, and 0 1 2, and for k is equal to 3 we had again 2 under root 2. So this was our lecture. Thank you for watching. See you next time.